Good everyone, my name is Graphics. In this video, we want to solve the problem that is displayed on the screen. And the question goes like this. It says, if alpha and beta are the roots of x squared minus 7x plus 2 equals to 0, evaluate the following. A, alpha over beta plus beta over alpha. B, alpha over beta squared plus beta over alpha squared. C, alpha squared over beta plus beta squared over alpha. D, 1 over beta plus 2 plus 1 over alpha plus 2. E, 2 minus alpha over 3 plus beta plus 2 minus beta over 3 plus alpha. F, alpha squared over beta squared plus beta squared over alpha squared. Now, solution. The first thing you do in situations like this, whenever you are given a question on quadratic roots, is for you to find the value of alpha beta and alpha plus beta. We know alpha beta is c over a and alpha plus beta is minus b over a. So we need to look for a, b, and what? And c. So how are we going to achieve this? Now look. The given equation here is x squared minus 7x plus 2 equals to 0. I will tag that equation 1. Recall, we know that a quadratic equation is always written in the form of what? As squared plus bs plus c equals to 0. I'll tag that equation 2. Now what will I do? I'll compare equation 1 and 2. So comparing equation 1 and 2, therefore consider s squared such that, now when you're considering s squared, if you look at equation 2, the quotient of s squared is a, right? And in equation 1, the quotient of s squared is what? Is 1, because there's nothing there. So we'll now say that a is equals to what? 1. You could get the logic? Now let's consider x such that if you look at the quotient of x in equation 2, it is what? It is b. That is what is close to x. That's what they mean by quotient of x. So what is close to x here is b. And if you look at equation 1, what is close to x here is what? Minus 7. So it means that b is equals to what? Minus 7. Now let's look at the constant that we will call it s to the power 0, which is 1. Such that if you look at equation 2, the constant there is what? C. At equation 1, constant there is what? 2. So it means that c is equals to what? C equals to 2. So we've gotten the value of a, b, and c. Now recall, we know that alpha beta is equals to c over a, and what is c? C is giving us 2, and what is a? A is giving us 1, right? So we'll say that, and we know 2 over 1 is equals to what? 2. Then alpha plus beta is giving us minus b over a, which will now give us minus b. We know b is what? Minus 7, so we have minus in bracket minus 7 all over a, and a is 1, and that will give us what? 7, because minus times minus will give you plus. So this is what we have. So we have successfully gotten alpha beta and what? Alpha plus beta, right? So we move forward. What you will now do is that everything you see from a to f, you must simplify them to the form of what? Alpha beta and alpha plus beta, no matter what, because you only have the answers of alpha beta and also alpha plus beta, which is 2 and 7 respectively. So whatever you are doing when simplifying each of these questions, ensure you simplify them in the form of alpha beta and alpha plus beta. So let's start. Question A, we have alpha over beta plus beta over alpha. Now when you look for the LCM, you'll be having alpha times beta, that is the denominator, right? What is under, you multiply both of them. Now if you want to get the numerator, you take alpha from here to multiply alpha, you have alpha squared, plus you take beta from here to multiply beta, here you have beta squared. This is what we have here, but we don't know the answer or the value of alpha squared plus beta squared. Now this should now be equals to, you write down the denominator, which is divided by alpha beta. So we'll now be focusing more on what alpha square plus beta square is. So what we have to do, we have to simplify alpha square plus beta square into the form of either alpha beta or alpha plus beta. And now we're going to do that. Now let me do that as my side working here. It's not necessary you must know how to do it, but you should know it for the benefit of knowledge. Now if you look at this, you can get this alpha square plus beta square from the expansion of alpha plus beta all square. How did I mean? Now watch. Alpha plus beta all square, if I expand this, I'll be having alpha square plus beta square plus 2 alpha beta. Now you'll be wondering, how did I get this? This is how I got it. If you square the variable inside, because it has a power of 2, so you'll be having alpha all square, right? When you're considering alpha. Then when you consider beta, we have beta all square. Now you now multiply everything all together, the power and what is inside the bracket. So 2 times alpha times beta will give you 2 alpha beta. So that's what I did, I got that. Now what are we looking for? We're looking for alpha square plus beta square. Now you leave that where it is and you take plus 2 alpha beta to the other side. And when you're taking plus 2 alpha beta to the other side to give you minus 2 alpha beta. Am I correct? So you now be left with alpha plus beta all square minus 2 alpha beta. So this is what I'm going to put here, right? So we'll put it in the form of alpha plus beta and alpha beta. You can see that? So from our question here, what do you have the value of alpha plus beta? It is 7. So I'll replace alpha plus beta as 7 all square minus 2. What I have as alpha beta, I'm having what? 2. So minus 2 times 2 all over alpha beta, which is 2. So what we have here, this will now give us 7 squared is 49 minus 2 times 2 is 4 all over 2. So my answer to this question A will now be what? 49 over 4, that will be 45 all over what? All over 2. That is the answer here. Is that okay now? So we'll move to the next question. So let me write it out. If you notice it, alpha square plus beta square is what? Is 45, and alpha beta is what? Is 2. So anytime I see alpha square plus beta square, I'm going to put 45. So let me write it out here. Always remember that. So we have three things now. We have alpha beta, we have alpha plus beta, we have alpha square plus what? Plus beta square. So you know that. So let's go to question B. Question B is telling us that we should evaluate alpha over beta square plus beta over alpha square. You do the same thing. The LCM here is alpha square beta square. Is that taken? Now you take the alpha square here to multiply the alpha, you'll be having alpha cube, plus the beta square here to multiply the beta, you'll be having what? Beta cube. Is that taken? Now this will now give us here the alpha square beta square can also be written as alpha beta all square, your indices, because when you have ab raised to power m to give you ab raised to power n to give you an bn. Can you see that? So this is what we have. So when you have a square b square to give you a, when you have alpha square beta square to give you alpha beta all square indices, right? So now, but I don't have the relationship of alpha cube plus beta cube, because from what I have from the question, I only have alpha beta and alpha plus beta with the just included one, which is alpha square plus beta square, right? So let's now see how we can expand alpha cube plus beta cube. Now you can get alpha cube plus beta cube from the expansion of alpha plus beta all cube. How do I mean? Now watch. When you have alpha plus beta all cube and you are expanding it, you're going to be having alpha cube plus 3 alpha square beta plus 3 alpha beta square plus beta cube. Are we together? So now this is what we have here. If you expand this, and if you want to know how to expand this, this is how we did it. Let's come back again. If I have alpha plus beta all cube, it means alpha plus beta times alpha plus beta times alpha plus beta. Just like when you have a cube, you'll be having a times a times a. That will give you a cube. Is that taken? Now, if I expand the last two here, these two here, this and this, right? I'll be having alpha plus beta in bracket. You know, when you expand this earlier, you'll be having alpha square plus 3 plus 2 alpha beta plus beta square. Is that taken when you remember what we did? Now, if you take the alpha here to multiply the alpha square here, you'll be having alpha cube. If you take the alpha here to multiply the 2 alpha beta, you'll be having 2 alpha square beta. If you take the alpha here to multiply the beta square here, you'll be having alpha beta square. And if you take the alpha here to multiply, if you take the beta here to multiply the alpha square, you'll be having alpha square beta. And if you take the beta here to multiply the 2 alpha beta, you'll be having 2 alpha beta square. And if you use the beta here to multiply the beta square here, you'll be having what? Beta cube. This is the expansion. Taking the first one, multiply everything, the first one in the first bracket, multiply everything in the second bracket, and you take the second one in the first bracket to multiply everything in the second bracket. Is that taken? And when you collect your like terms, you will now say that my alpha plus beta all cube will be equals to alpha cube plus 2 alpha square beta plus 1 alpha square beta will give you 3 alpha square beta plus 2 plus alpha plus 2 alpha beta square plus alpha beta square will give you what? 3 alpha beta square. Then we have plus what? Beta cube. This is the expansion I told you earlier. Now, we have this. What are we looking for? We're looking for alpha cube plus beta cube. Am I correct? Now, if I take everything to the other side and leave only alpha cube and beta cube at the right hand side, I'll be having alpha plus beta all cube minus 3 alpha square beta minus 3 alpha beta square equals to what we have here, alpha cube plus what? Beta cube. Is that again? Now, we need to put it in the form of alpha, beta, and alpha plus beta. And we're still having some different thing here. So you have to simplify it further. So let me now bring out minus 3 alpha square beta minus 3 alpha beta square and see what I can do to that. So look at this here now. Now when I have minus 3 alpha square beta minus 3 alpha beta square, right? If I should factorize it, what is common to both sides? Minus is common to both sides. So when I bring out minus, means minus will disappear. And when minus disappear, it will remain plus. So we're having plus here remaining, right? What else is common to both sides again? 3 is common to both sides. So if I bring out 3 out, means 3 will disappear from both of them. So we're having just alpha square beta plus alpha plus alpha beta square. Is that taken? Now, if you look again, what is common to both sides? Alpha is common. So if I remove one alpha from alpha square, I'll be left with one alpha beta. And if I remove one alpha here from alpha beta square, I'll be left with what? Just beta square. So we're having what? Alpha beta minus what? Beta square plus beta square. Right? Now, if you look at it, what is common again? What's common here is what? We have those beta here. So when I bring beta out, beta will disappear from inside the bracket. So I'll be left with what? Minus 3 alpha beta in brackets alpha plus beta. That what we have in there, right? So that's what I'm going to put here. So when you put it here, you now be having alpha plus beta all cube minus 3 alpha beta in bracket alpha plus beta. That will now give us alpha cube plus beta cube. So what I just did here that you see is what we call factorization, right? That what we call factorization. So this is what I will put in whenever I see alpha cube plus what? Beta cube. So let me write it out here. So I'm having what I've placed it there. You can see that alpha plus beta all cube minus 3 alpha beta in bracket alpha plus beta. So from our question, what is alpha beta? Alpha beta is 7 and there's a cube there, so we have 7 cube minus what is alpha beta? Alpha beta is 2, so we have minus 3 times 2 times 7 because alpha plus beta is also 7. So this will now give me everything all over what? Alpha beta is still 2, so we have 2 squared. So this will now give me 7 cube, right, will give us 343 minus 3 times 2 times 7 will give us 42 all over 2 squares giving us 4. So my answer will now give me 301 all over 4. That is the answer to that question. And one thing I want you to understand, you see what we have here? On top of here, we have alpha cube plus beta cube, right? And that is everything here. So that is everything that will give me 301. So whenever you see alpha cube plus beta cube, it will be what? 301. And whenever you see alpha beta all square, that will be what? That will be 4. But let me focus on alpha cube plus what? Beta cube. So let me write it out here. So we have 3 now, I'll be 4 of them. Alpha beta, alpha plus beta, alpha square plus beta square, alpha cube plus what? Beta cube. These 4 of them. If you can put them in your head, no problem. If you can know how to prove them the way I showed you, no problem. But what you just need is just the relationship. So we move forward to the next question, question C. And question C is telling me alpha square over beta plus beta square over alpha, right? So when you look for the LCM again, you'll be having alpha beta, what is under. And when you multiply, you use alpha to multiply alpha square, you'll be having alpha cube. Plus you use beta to multiply beta square, you'll be having beta cube. And this will now give me, you know, the relationship of alpha cube plus beta cube. That is alpha plus beta all cube minus 3 alpha beta in bracket alpha plus beta, right? Or what we did earlier, all over alpha plus beta. And we know what alpha cube plus beta cube is. You can see it from up here. That is what? 301, right? So I'll write my 301 directly there. All over, you know what alpha beta is. You can see there. That is what? That is 2. So 301 all over 2, that will be my answer. Is that okay now? So we move forward to the next question. Question D. It says we should evaluate 1 over beta plus 2 plus 1 over alpha plus 2. If you look for the LCM, you consider the two denominator, that will be beta plus 2 multiplied by alpha plus 2, right? So you take this to multiply this. So alpha plus 2 times 1 will give you alpha plus 2 plus beta plus 2 times 1 will give you beta plus 2. All divided by what you have here, right? Then so now give me collect like terms. Alpha plus beta plus 2 plus 2 is what? 4, right? Put the alpha plus beta in the bracket. Is that taken? All over, if you expand the denominator here, from the first bracket, beta times alpha give you alpha beta. From the first bracket, beta times 2 in the second bracket will give you 2 beta. From the first bracket, 2 times alpha will give you 2 alpha. From the first bracket, take 2 times 2 in the second bracket to give you what? 4. So what I mean is take the first beta, multiply everything in the second bracket, take the second value which is 2, multiply everything in the second bracket, you have this. Now you collect like terms. So I'll be having alpha plus beta plus 4 all over alpha beta plus, you see, between, look at this now, 2 beta plus 2 alpha. What is common to both sides? 2. So when you bring 2 out, what will remain? Mean that 2 disappear inside, right? So we're left with just beta plus alpha, which is saying alpha plus beta. So that's what I'll put here. So 2 into bracket alpha plus beta, then plus 4. So I've taken it to the form of alpha plus beta and alpha beta. So put in your value now. So we have alpha plus beta is 7 plus 4 all over alpha beta is 2 plus 2 in bracket 7 plus 4, right? And this will now give me 7 plus 4 is 11 all over 2 plus 14 is 16 plus 4, that is 20. So my answer here is what? 11 all over what? All over 20. That is the answer to D. So let's go for E. So for E here, it says to evaluate 2 minus alpha all over 3 plus beta plus 2 minus beta all over 3 plus alpha. You do the same thing. You get the LCM. LCM is multiplying the two denominator, and that will be 3 plus beta multiplied by 3 plus alpha. Now take this to multiply this. That is 3 plus alpha times 2 minus alpha plus 3 plus beta times 2 minus beta is what we have here, right? So from what we have here, we'll now be having you will now expand them. So expanding it, you're going to be having 2, use 2 in the first bracket to multiply everything in the second bracket, and use minus alpha in the first bracket to multiply everything in the second bracket, and you'll be left with what? 6 plus 2 alpha minus 3 alpha minus alpha square. Is that taken? Plus, you do the same thing for the second one. You take 2 here in the first bracket to multiply everything in the second bracket, and you take minus beta in the first bracket to multiply everything in the second bracket, and you're going to be having 6 plus 2 beta minus 3 beta minus beta square. Alright, all divided by what you can see here, 3 plus beta multiplied by 3 plus alpha. Is that taken? Now you collect like terms. Now collecting like terms, I'll be having 2 12, that is 6 plus 6 is 12, minus, now if you look at 2 alpha minus 3 alpha will give you minus alpha, then minus alpha square, 2 beta minus 3 beta will give you minus beta, right? So minus beta square. Is that okay now? So with this, you bring, like I told you, they should always be in the form of alpha and beta. So with this I have here now, I'll have 12 minus alpha minus beta minus alpha square minus beta square. So when you consider 12, 12 is alone. Now when you consider minus alpha minus beta, what is common to both sides? You can see from the screen, what is common to both sides? Minus. When I bring minus, what remains inside will be plus. So I'll be having minus alpha plus beta. Same thing when you have minus alpha square minus beta square, what is common? Minus. So you bring minus out to remain plus, inside we're having minus in bracket alpha square plus beta square. Is that okay? So we'll now be left with, we have 12 here, minus alpha beta is 7. So 7 minus alpha square plus beta, from what you can see on the screen here, that is 45. All over 9 plus, if you do the same thing under here, right, what is common to both sides here? It is what? It is 3. So if I bring 3 out, I'll be left with what? Alpha plus beta plus alpha beta. So we're having 9 plus 3 in bracket, alpha plus beta is 7. So we have 7 plus what? Alpha beta is 2. So we'll now be having 12 minus 7 minus 45. That will give me minus 40. All over 9 plus 3 times 7, that is 30. So 30 plus 2 is 32. So if you divide this, you're going to be having minus 5 over 4. How? Because 2 can go in 40 20 times, 2 can go in 32 16. It can still be divided further. 2 in 20 is 10, 2 in 16 is 8. It can still be divided further. 2 in 10 is 5, and 2 in 8 is what? Is 4. This is what we have here. Minus what? Minus 4 over what? Minus 5 over 4. All together. So what we have here, that is what my answer is. You can try the sixth one for yourself. Is that okay? You can pause the video and try the sixth question that says that evaluate s square over b square alpha square over beta square plus beta square over alpha square. Do the same procedure, right? So you can try that you can pause the video and try that for yourself. But for the benefit of others, let me just show you what to do. So from here, look for the LCM. We have alpha square and beta square. Take alpha square to multiply alpha square, you'll be having alpha to the power of 4, right? So because indices now. Now take beta square, multiply beta square, we're having beta to the power of 4. So this is what we have here. Alpha to the power of 4 plus beta to the power of 4 all over alpha square plus beta square. Now in your indices, I can rewrite it this way by saying alpha square square plus beta square square all over alpha beta all square. You understand? I explained this earlier to you, right? When you say 2 times 2, it will give you what? 4. It's the same thing. Your indices, when you have a to the power of n into bracket what? Into bracket x, right? To give you a to the power of what? Nx. It's the same thing. Now if you look at this relationship, alpha square square plus beta square square, right? You can get this from, we know that alpha square plus beta square is going to give us alpha plus beta all square minus 2 alpha beta. Remember that? Yeah. Now, if I now square alpha square here, it means all the alpha I have here will have square. If I also square beta square here, it means all the beta here will have square. And this can be written as, again, alpha square plus beta square all square minus 2 alpha beta all square. So this is what you have when you have this. So let's input our parameter. So this is what I'm writing here now when you see this. Is that again? All over alpha beta all square. So if I put my parameters here, my alpha square plus beta square is giving me 45, as you can see from here. All square minus 2 into bracket, alpha beta is 2, put your 2, all square. All over alpha beta all square, which is 2 square also. So my 45 square is 2025, minus 2 square is 4, 4 times 2 is 8, all over 2 square, that is what? 4. So if you subtract 2025 minus 8, you have 2017 all over what? 4. That is my answer. So if you find the video helpful, don't forget to like and also subscribe.